I'm really pleased to introduce today Malte Pietsch. He's going to talk about connecting GPT with your data and how to avoid hallucination, which is something that we obviously talked about in the Q&A about an hour ago. Malte is the co-founder and CTO at DeepSet, where he builds Haystack and DeepSet Cloud to enable developers all over the world to use NLP effectively in their business applications. Previously, he conducted NLP research at Carnegie Mellon University and was a data scientist for multiple startups. He's been crafting NLP applications for all kinds of businesses for more than 8 years now, and is convinced that the development workflow and user orientation are key criteria for successful NLP projects. So, Malte, please take it away.
Thanks, John. Thanks for the kind intro. I'm super happy to be here today and share a few of our thoughts on LLMs. Welcome to the session. And I think we are all aware that LLMs are the future, right? And that they actually unlocked already many exciting use cases. We already heard about a few in the sessions earlier today. Still, I personally feel that there's sometimes two realities out there. There's this crazy buzzworld when I open my Twitter feed, for example, where everything seems possible and so easy. And then there's enterprise reality when I talk to engineers, product managers out there in the industry. So if we look at the title of this whole event today, my talk will be more on the pitfall side of things. And I want to share some of our learnings, some of the challenges we basically saw with our enterprise customers when building LLM applications for production use cases. To give this whole session a useful and positive twist, I will, of course, not only share pitfalls, but also some pragmatic tips to actually overcome them. So in the next 20 minutes, I will give you an overview over the most common challenges when building LLM applications, then highlight one key method that helps a lot to overcome some of these challenges, and then walk you through some additional smaller tips on what you could actually do to optimize things even further. So let's get started with the most common challenges we observed with our customers when building LLM applications. Number one, most of these high-value use cases we see in the enterprise include some kind of internal company data. So that is data that is not available in the public internet. It's often from a special domain, could be, for example, aircraft maintenance documents, could be legal contracts or financial reports. And the typical question that comes up then is, how can we tune the model now to our data? How can we teach it about our internal knowledge that it doesn't know yet about? Challenge number two is actually closely related to this first one. When our use case now relies on this internal data, how can we make sure we stay in control of it? I mean, must be safe, must be secure. Maybe our company policy doesn't allow sharing this kind of data with third parties. Number three, if you overcome these first two challenges, the next big question is typically around quality assurance. So once you want to go on production. I think we all saw these models hallucinating, simply making up answers. And if your application is being exposed to customers, for example, this could be extremely damaging to your brand. So how do you know if this is safe enough to deploy? How can you assess this kind of quality? I could probably talk about each of those challenges for hours. Today, I just want to focus on challenge 1 and 3 and get there the key ideas across. So let's start with the basics. What is actually an hallucination? Why does it happen? Well, LLMs are often wrong with their answers, and even worse, they are confident about it. So some of you might remember this bank that used to exist, Silicon Valley Bank, and if you ask an LLM if Silicon Valley Bank collapsed, you can easily get an answer like this. No, it did not collapse. It's a successful financial service company, da, da, da. This is what we call hallucination. The model is simply making up a fake reality. So let's try something else. What if we asked, why did Silicon Valley Bank collapse? All of a sudden, the model switches its opinion. Now SVB actually collapsed. Great. It's even giving us some arguments why the bank failed. But wait, it's mentioning something around subprime mortgages and financial crisis of 2008. I'm honestly very bad with remembering dates and timelines, but even I'm pretty sure that SVB was happening this year and not back then in 2008. And it was actually related to rising interest rates and a bank run, not subprime mortgages. So this kind of behavior is what causes problems when developing an LLM application. The model is not stable in its opinion, it's giving wrong answers, and it's often very eloquent in its argumentation. It can sound very convincing. And this makes it really hard to spot these kind of hallucinations as a user. Where do these hallucinations now come from? Well, in this case, it's probably rather easy. SVB happened this year. This LLM that I asked here only saw training data until September 2021. So its internal knowledge is simply outdated. It could most likely be fixed by training another model on more recent web data. Okay, cool. So are hallucinations only a problem when we ask about this kind of recent events? Unfortunately not. So let's ask GPT about something in 2008. Let's ask about the number of Model 3 vehicles that Tesla produced in the first quarter of that year. The answer that we get here sounds convincing. It's even mentioning a source, the shareholder letter. However, if you open this shareholder letter, you find that this number is unfortunately completely wrong. Instead, 9,700 vehicles of that type were produced. So why did this model hallucinate here? Either it did not see any information about this at all at training time. This is quite unlikely in this case, as it mentions explicitly this kind of shareholder letter. Or, well, the more likely option in this case, the model actually has seen some related information, but mixes it up. It's not confident enough, it maybe hasn't seen enough examples of it, it's guessing. And indeed, if you look through the shareholder letter, this number of 34,000 cars that the model brings up here is the total number of vehicles produced in that quarter, not for Model 3. So now that we know what hallucinations are, how can we actually reduce them to ensure quality in production? And let's not forget about our second challenge. How can we teach the LLM new information if our use case is about this internal company data? Turns out there's one key method that can actually really help with both of these challenges. It's called retrieval augmentation. Let me explain you the key idea of this method. Let's first see how an answer gets generated by an LLM in the standard way. So first, you have your question. This is typically converted to a prompt, which contains still your original question, but then also maybe some optional text around it to instruct the model what to do actually, and maybe in what style it should respond. This prompt is then sent to an LLM, and this generates the answer that we then see. Simple. Now, let's look what changes with this approach of retrieval augmentation. We still have our question here on the left. We still have a prompt that gets fed to our LLM. However, what we do now is inserting some more information in our prompt, what you see in green here. So what we want to provide the LLM with some more useful information that helps the model to answer our question in a really truthful way. So in our example of Silicon Valley Bank, this could be news articles or analyst reports that explain this collapse of the bank. Of course, we need some automatic way of searching and inserting these relevant documents in here. We can't do this manually. So what we do is now connecting our pipeline to some external database and use a so-called retriever model to find us a few relevant documents that we can then insert basically into our prompt. So think of it as a search. First search relevant piece of information and then insert it into our prompt. And when we do that, we can actually solve now several problems at once. First of all, we reduce hallucinations as the model will now ground its answers on some actual information in the documents. We can also teach now the LLM new information so that it stays up to date and also becomes aware of our kind of private company data that we might have in this database. Last but not least, it helps with explainability and verifiability for users. So as a user, I can now very easily browse the documents behind my generated answer, similar to what we heard earlier in the talk about Bing. I can verify that these answers make sense and where they come from. So let's now have a quick live demo and see this in action. So this is a small demo that we put together. It's on Hugging Face basis, so all of you can actually access it. It's using Haystack, our open source framework, under the hood. All code is also available here under files. And what you can do here now is basically asking questions around the Silicon Valley Bank collapse. So we have here already one example, did SVB collapse? And then we see basically two different answers, one using plain GPT and one using GPT with retrieval augmentation. And you can switch basically the data set that is used. You can either use a static news data set, some articles, or you can do live web search to augment your prompt. So let's maybe try one of these queries, run it. And yeah, above here we see again some plain answer with hallucination, and down here we should hopefully see also we should see actual the SVB collapse due to a bank run caused by VCs and founders withdrawing their funds. Headwinds from continued higher interest rates. So that seems like more truthful. And we can even kind of browse the source, the text behind it that was used to generate this answer. So have a look at it, play around with it. It's out there. You can not only play around with it, but there's also linked here in the slides the code for the demo and a tutorial that actually walks you through how you can build this easily with open source code yourself. Something like this should probably like just some pipeline take you an hour to build yourself. So now that we learned about one key method, retrieval augmentation, what can we do on top to have less hallucination? We can actually do a lot. Let me use the remaining few minutes now to share some quick tips and general directions that you can then further explore yourself, or we can discuss them in our Q&A session in the breakout room. So my first tip would be invest some time in optimizing your prompts. A few things that we found particularly helpful here in practice, allowing the model to say, I don't know. It should often rather return nothing than a wrong answer. Depends a lot on your use case, but in many use cases, you rather prefer this. And you can actually simply instruct your model to do so. One example prompt you see here on the slide, in green, there's basically the instruction that the model should say, I don't know, when the information is not grounded or the answer is not grounded actually in the documents. Two things that are less obvious, but work astonishingly well in practice. You can instruct the model with a different task that you actually have in mind. So for example, formulate it rather like a summarization task and less like a question answering task in our example here. You can also formulate the document context like the opinion of a person. So these are nice little tricks to ground the model even more in this context that we provide, even more in the documents that we give it to them. There's a nice recent paper I linked also here from Zhu et al., where they show that this opinion-based approach actually reduces hallucination quite a bit. And for the summarization task trick, this is based on our own experience in a recent customer project. There we actually made the observation that you have generally less hallucination in summarization tasks, and we kind of hijacked this now for Q&A tasks as well. My intuition here would be that probably related to how these models were trained via reinforcement learning on this kind of human feedback. And maybe the labelers were kind of stricter for summarization tasks. They labeled slightly different that penalizes hallucinations even more. So there's much more you can do, of course, but that was, for now, prompt engineering at a glimpse. Let's now spend a few more minutes on other useful directions. What else can we do beyond prompt engineering? Well, so far, we optimized the input to the LLM. If you look at this chart here, we basically just what goes into the LLM. Is there maybe also something we can do after the LLM when we got back the generated answer? Yes, for sure, there is something. And one of these helpful things that you can do there is so-called self-reflection. This is basically the idea of letting the model reflect on its own generated response and give the model a chance to correct it. Let's look at a basic example. Let's ask the LLM who the CEO of Twitter is. And as we know, this has rather recently changed. We also supply directly the information that is actually needed to answer our question. We let the model already know that Elon Musk is the actual owner and CEO, just as we would do with a retrieval augmentation approach. If we look now at the response, this is a bit disappointing. The model ignored the extra information we provided. It warns us about its internal knowledge cutoff, which is nice, okay. But it actually did not really answer our question. So what can we do to now improve this answer? We can actually ask a follow-up question. In a simple example, we can just ask if the answer is really reflecting the information we shared with the model. And as you can see, it helps. Next response is basically containing what we're after. The model corrects itself. You can, of course, now do these follow-up questions manually as a user, but we can also automate this in our application. If you automated this, then typically what you call self-reflection. You would add a step in your pipeline that asks these kind of questions automatically. Okay, so now we talked a lot about practical ways of reducing hallucinations. But how do we know that we actually improve? How can we be sure that the level of hallucinations is acceptable for our production application? Well, ideally, we would have a way of detecting and measuring hallucinations, just like any other metric we have for machine learning models. Unfortunately, it turns out that this is not easy. It's, I would say, one of the probably biggest unsolved problems in the generative AI space and a super active area of research. It's not like that there are no methods out there. There are actually quite a few. Just honestly, I haven't seen them working very well yet. They are developing. You can categorize these approaches that are out there in 3 buckets. And in each of these buckets, I think we see great advances and things are developing. So let me walk you quickly through these buckets and different approaches. They are statistical metrics. Think of it as classical machine learning metrics like F1, Rouge, Meteor. Very easy to compute, relying on some kind of statistical formula. We benchmarked a few of them recently. Unfortunately, they are not working very well for detecting hallucinations. The main problem, they don't correlate well with human judgments. So a human would flag something differently than this metric. They would tag different answers as hallucinations that this metric doesn't get. Which brings me to my next point. Collecting human feedback is currently probably the most precise thing you can do. You can ask some users to check the predictions of your prototype pipeline and kind of tag all hallucinations. This, of course, works. You get some metric out of it. With the right tooling, this doesn't take too much time either. And we can actually do this, quite a lot with our customers. However, it's still quite some manual effort is involved there, right? And maybe you can do it once or twice before going to production. But what then? How can you continuously monitor hallucinations of your live application? So somehow we still really want an automated way of detecting hallucinations. And this is where the third approach out there fits in and is at least quite promising. which is model-based detection of hallucination. This approach lets you detect hallucinations automatically by just using another machine learning model that is specialized for this task. The only problem, so far there's no really good model specialized for it out there. And that's why we decided to train such a model ourselves. So let me give you a very quick sneak preview of what we work on right now there. So the idea is straightforward. The model that we train takes two inputs, a generated answer, and then some ground truth data that it can compare to. And in the case of retrieval augmentation, we have this actually for free. We have our retrieved documents, which already contain the kind of base information, and we can use this as kind of ground truth data. So the model gets those two text inputs and then classifies if the generated answer from the LLM is actually grounded in the retrieved documents or not. And it returns a score between 0 and 1. We call it faithfulness score. And with that score, we can now automatically evaluate every answer our model generates. And depending on our use case, route questions differently or answers differently, add a self-reflection loop or whatever you want to do with this answer. So this model is still in the making on our side, but be assured, once we have a model here, we will open source this, so stay tuned. Yeah, and with that, I'm also already coming to an end of this short session. I hope you saw threat of hallucinations is real, and it's not only about outdated information. We also saw how retrieval augmentation can actually help with reducing these hallucinations, but also tailoring your responses to the own data. And I shared a few directions, like tips, what you can do further. Last but not least, I also want to stress that this not only holds for simple pipelines with a single LLM call, but also for more complex systems like agents with often dozens of LLM calls. To make these agents actually robust, it's even more important to reduce hallucinations and detect them, monitor them. Yeah, and with that, thank you.